Good morning, guys. Mr. Milton here. Today we're going to talk about properties of parallel lines. Okay. Um, at the end of this lesson, we should be able to recognize the different angle relationships when a transversal cuts through two parallel lines. Um, we'll be able to justify angle measures using the theorems about alternate interior angles and same-side interior angles or consecutive interior angles and corresponding angles, and we'll be able to use the properties of parallel lines to solve real life problems. Okay. All right, let's get started. First, it probably would be wise to know what a transversal is. Okay, a transversal is a line that intersects two coplanar lines. So in these diagrams, you can see the transversal here. Transversal. Here's the transversal as well. And here's the transversal. Okay, notice in all these diagrams, transversal, that the transversal intersects the parallel lines. Okay, now it doesn't have to intersect the parallel lines, but transversal does intersect two other lines. Okay, now when that transversal intersects the lines, we just focus on this diagram with me, this top one. Notice that without the transversal, there would just be two lines in space. Okay, but that transversal makes 1, 2, 3, 4, 5, 6, 7, 8 angles. Okay, makes us 8 angles. Okay, and when lines are parallel, those 8 angles have, pairs of them have unique or special properties, and that's what we'll talk about today. Okay, we'll talk about 3 pairs of angles, and then how we can use those pairs to find out the measure of each of the angles in the diagram. Okay, and so it's going to be important for you to remember these names, how to recognize the pairs, and we'll try to work on that today. And obviously their properties. So that's what it's about, properties of parallel lines. Alright, so the first pair we'll talk about today is same-side interior angles. Okay, this one's the easiest for me to remember because the name kind of says what it is. If you think about the two lines, okay, the two parallel lines is usually how we deal with this. Same side of the parallel lines, or same side of the transversal and interior of the parallel lines. Okay, so angle 6 and angle 5 are examples of same side interior, inside the lines on the same side of the transversal. Okay, and as you get more practice with this, I think it'll be easier to identify. But if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. Okay, and from last chapter, you should remember that supplementary means that they add up to 180 degrees. Okay, so measure of angle 5 plus measure of angle 6 equals 180. And that'll happen each time that the transversal intersects two parallel lines. Okay. Alternate interior angles. Again, this interior is referring to the parallel lines that we're dealing with. Okay, so you have two parallel lines inside interior, and then alternate means alternate sides on alternate sides. So it says same side interior. I guess you could call it alternate sides interior, but it doesn't sound as nice. Okay, so with alternate interior angles, so we have angle 3 here, angle 4 here. The theorem goes if two parallel lines are cut by a transversal, two parallel lines, the transversal, then the pair of alternate interior angles, angle 3, angle 4, are congruent. Okay. Alright, and the last one, corresponding angles. Okay, this is the corresponding angles theorem. says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent as well. Another way I rationalize what corresponding angles means, or how to identify what corresponding angles are, is I look at the transversal in each of the parallel lines. Okay? So in this case, angle 1 and angle 2 are kind of marked for us. If you look at angle 1, okay, it's made of the top line and the transversal. It is you see the 4 angles created here, 1, 2, 3, 4. It's the top right angle created by that line and is transversal. Okay. Angle 2 deals with the transversal on the bottom line. Okay, if you look at the 4 angles that are created by the transversal in that line, angle 2 is the top right angle as well. Okay, and so those angles correspond and they're in the same position. Okay, and that's how I rationalize how to think of why name it corresponding. Okay. Now, a big takeaway that I want you to remember is that these angles or these relationships are true when it intersects two parallel lines. Two parallel lines. Notice that that's in each theorem or postulate. Okay. These postulates only tell us what they add up to or what their measures are if our transversals intersecting parallel lines. If we had a diagram, let's say two lines that aren't necessarily parallel, okay, so I'm making them obviously not parallel. Okay, this will be our transversal in this case, still a transversal because it intersects two lines. Okay, that would be our transversal. But our same side interior angles, let me see if I'll get a pair of same side interior angles. Excuse me. Well, I can identify these as same side interior angles, angle 1 and angle 2 as same side interior angles, because these lines that the transversal intersect aren't parallel. They would not add up to 180. They only add up to 180 if the transversal intersects parallel lines. Okay, and that goes for alternate interior angles. Angle 2 and angle 3 would be alternate interior angles. We could classify them as that, but they wouldn't necessarily be congruent. They would only be congruent if two lines parallel. Okay, since these two lines aren't parallel, or at least don't appear to be parallel, they wouldn't be congruent. Okay. Alright, so that's just a reminder that these angle pairs are always present, but they only have these special relationships of being supplementary for same side interior angles, congruent for alternate and corresponding angles if it's two parallel lines. Okay. Alright, let's go in the back and work on some examples. Alright. First example. They gave us that the measure of angle 1 is 105 degrees. They want us to find the measure of each angle and justify our answers with a theorem or postulate. Okay. So they told me that this is 105 degrees. I'll write this here because it's easier to, visualize it once you have it down. Okay, so they want us to start with angle 3. Angle 3. Angle 1 and angle 3. What kind of angles are these? This is the top right of the line, the parallel lines. Okay. Oops, and let me make sure we mention that we can tell that these are parallel lines because the arrows indicate that they are. Okay, these arrows on the line is our sign that our lines have the same slope or are parallel. Alright, so this is 105 degrees. Angle 3 would be 105 degrees because of corresponding angles. Okay, corresponding angles postulate. Okay, I'll write 105 here. Angle 4 would be 105 degrees as well. Okay, and not because of anything that we saw today, but if you notice that angle 3 and angle 4 are vertical angles. Vertical, I think that's how you spell it. Okay, and we know from last chapter that vertical angles are always congruent. Angle 2, notice that angle 2 and angle 3 are same side interior angles, so they should add up to 180. So I can say 180 minus 105, and that gives me 75. So angle 2 should be 75 degrees, and that's because they're same side interior angles. Ooh. I guess I should say Engel's theorem. I'll abbreviate more next time. Okay. So I'll write 75 here. Alright, and then the measure of angle 5, well, angle 2 is here. Angle 5 is its alternate interior angle. Okay, so it'll be the same. Alternate interior angles are congruent. All interior angles there. Alright, and so there we go. Those are all of our angles. Alright, you pause it, take a second, go through the next example here on your turn. Okay, I'll go through that maybe a little bit faster, but I'll give you a second to pause and try it on your own. Okay, measure of angle 6 is 54. Measure of angle 7 is 54 because of alternate interior angles. Okay. Measure of angle 8. They don't tell us, but these two add up to 180. They're a linear pair. Again, something else we learned last chapter. So 180 minus 54 is 126. The measure of angle 9, again 54 plus angle 6 plus angle 9 should be 180 because they're same side interior angles. Same side interior angles theorem. Okay. And so that's 126 as well. And the measure of angle 10 is 54. Okay. Because of vertical angles. Okay, vertical angles are always congruent. Alright, so some of your problems will just look like lines. Okay, two parallel lines and a transversal. And some of your problems will have diagrams of shapes. Okay, whether we have closed figure like this trapezoid here, or whether we have lines, the properties for parallel lines stay the same, and so we can still use it to find out our different measures. Alright, so let's look at this problem. They want us to use the figure to find x and y. Notice for this problem that they do tell us that these two lines are parallel, okay, with these arrows. Okay. One thing that might be helpful for you if you can't see the parallel lines and how it relates to what we've just done is to extend lines. Okay. Sometimes extending lines, whether they're straight or not, can remind you that hey, this is something we just did. These lines kind of remind us here of what we did here. Okay. And that'll be helpful for identifying special pairs. Because here I see that 2x and x minus 12 are same side interior angles. Okay, so I should add these up, and they should add up to 180 if our lines are parallel, which they told me they are. So 2x plus x minus 12 equals 180. 3x minus 12 will equal 180. 3x equals 192. X will equal 64. Okay, I should be able to check and make sure that that adds up to 180. This will be 128, 64 times 2. This will be 52. 64 minus 12 52 plus 128 equals 180. So I'm good. Alright? And then I can do the same thing for y. Well, almost the same thing. Okay? Again, these are parallel lines, and a transversal. These two are in the same position. They're same side interior angles. And so I know that 3y plus y plus 20 equals 180. So 4y equals 160. Y equals 40. And I could do the same thing. Plug 40 in, see that it works. And it does. 120, 60, adds up to 180. Okay, so here are my values for x and y using those relationships. Number 2 is a fun problem because you kind of have to use a few different things. Not a few. I'll say a couple different things. So they give you these two angles, 7x plus 1 and 10x minus 50. Initially, this isn't any of our relationships. Okay, these aren't vertical angles or corresponding or same side interior. So what we'll do, but what we can see is that these two angles are the same. Excuse me. And so we can kind of use it. These two are vertical angles. So I'm going to say that this is 10x minus 50. Hope I got that. Okay, so this is 10x minus 50. Now, moving this angle here because they're vertical angles, I can see that these two are actually congruent because they're corresponding angles. So that could set up my equation as 10x minus 50. Okay, and now I'm just solving it. Subtract 7x from both sides. Add 50. And get x equals 17. Alright, you guys try these too. Pause it if you need to. Alright, and I'll go just like we did last time. Parallel lines, same side interior angles. Nope. Alright. Alright, so most of the time people see angles and they want to put them together. Remember, there's only one pair that does not do that. Okay? Only one pair of angles that do not do that. That's same side interior. These two are same side interior. Same side interior angles add up to 180. Okay? They're supplementary. So I have 5x plus 5 equals 180. 5x will equal 175. X is 35. Alright. And so when I add these together, it should add up to 180. 80 plus, that's 105 minus 5, 100. So 180. There we go. Alright. Now number 2. These two are corresponding angles. Okay? So 3x equals 90. X will equal 30. Alright, we'll do some more practice with parallel lines.